Dear attendees, I'm Gilda Sigini, PhD Fellow in Mines Paris Graduate School in France, and my talk today will be on a work conducted in the framework of the Clean to Power project, a research project funded by GPI Climate, which aims at translating climate variables into power plant operational guidance. In this work, future climate trends are integrated into the operation of the power system in order to study its decarbonization. We evaluate four levels of carbon budget for the period from 2020 to 2050. They correspond to 80 to 50% of the volume with a constant annual emission level of 1,080 million tons of CO2 emitted over this period. Other hypotheses in the model are the development rhythms of capacities, phase-out dates for coal and nuclear, renewable potentials, and fuel cost. Before application of the climate variability impacts, the initial demand considered correspond to the EU reference scenario values. To study the long-term pathways, we use a detailed energy system optimization model built for the interconnected European power sector in the Markle-Times framework. The model describes the operation of the power system of 29 regions across Europe and the interconnections. A year is represented with 64 time slices. The model encompasses various current and future technologies, and investment and operation decisions are taken to minimize the total discounted cost of the system. The Clean to Power project builds on a comprehensive set of machine learning and simulation tools to convert temperature, wind speed, and precipitation data from EURO-CORDEX projections into national energy system input indicators. For this work, we consider a RCP 4.5 EURO-CORDEX projections, and the indicators we use correspond to hydropower capacity factors, wind and solar capacity factors, and variation in electricity and heat demand for each of the 29 regions studied. In the lowest budget case, where 50% of the base volume are cut, at least 37% of emission reductions are needed between 2016 and 2030. Across the scenarios, wind and solar keep a relative cost optimality as their share is between 47% and 59% of electricity generated in 2050. Trades are also impacted in the case of more cost restrictions, as the electricity flows in 2050 are 11% higher in the budget 50 scenario than in the budget 80 scenario. Thank you for your attention, and we warmly invite you to the result showcase of the Clean to Power project online on the 9th of November 2020. You can visit the Clean to Power website for more information about this project.